connect to this connection. See, no dropped frames, actually, nice. I also do this. Everything should still be fine. Yep, let me see if I can hear myself. It's fine. Nice. Good. So what are we doing today? We're doing greedy meshing. Open up GitHub desktop. So we have our to-do list here. I haven't done anything else on this branch yet. I don't know. It'll be interesting to see if greedy meshing doesn't work out, then I might investigate latticing again, but I don't know. I have a feeling that greedy meshing is the way. I have a feeling. And I've been also thinking it would be great if I could mesh the chunks without always iterating over every single block. So I might have some like intermediate value, I guess. Not intermediate value, but intermediate representation for the chunks, right? Where we note down like every single face. So let me actually go into the game. Load save here. So instead of, let me place down light. Instead of like noting down every single individual block here and recalculating the triangles and recombining all the triangles, if we have a section like this, let's say, and we have a section like this, we can just remember, oh, this is like a face, right? Like this exists here. And if we change a block in the same chunk like here, then, you know, we might have to do something to these grass faces, but we see that this hasn't been touched at all, right? So we don't have to like reiterate over every single block and figure everything out. It's just, you have to only touch the stuff that this block touched, right? That's what I'm thinking. It would mean more bookkeeping. You have to keep track of where the stuff actually changed. But it would eliminate most of this iteration, you know? And then the only thing you would have to do, like with the faces that already exist that weren't changed, basically just have to look at them and determine the triangles. And that's it. I don't think the face representation would take up a lot of memory either. I think it's gonna be pretty cheap. But yeah. I still don't know how exactly I can make this a non-blocking operation. Because as far as I know, I can't send any Godot types between threads. So if I spawn a thread and I make it mesh, I somehow have to join that to the main thread still. Possibly. And that's a problem. So I think my first approach is gonna be basically to try and optimize the meshing operation itself. Right? Mobile Diner, let's go, looking good. How's Rust and Godot run together? Pretty good. Aside from the multi-threading stuff that I was actually just complaining about. So sometimes there's a problem where you have some Godot types, like, you know, a pointer to a mesh instance node, or you have an array or like a variant or something. Yeah. You have something like that, and you just can't send that between threads for some reason. I if I remember correctly, for variants, it was that there's a raw pointer somewhere, and Rust doesn't like that. So it makes multi-threading a bit worse. Like I can offload work into threads, but then I have to join them to the main thread kind of always. And I'll have to figure out how how exactly I can do that. I'm thinking I might be able to do a meme where I have, let's see. I'll be able to have a vec of join handles. A vec of join handles, so when I spawn the thread, I just append the join handle. And then like when we remesh, we first check the vec. Like we iterate through all the join handles and we see if any of them are ready. And then we use the results if they are. That is actually something that would work. Yes, it would just mean that I have to spawn all the work in the main thread, and that's fine. So you can run Rust in a separate thread. I've never seen Rust in or with Godot. Well, I mean, how to say? Mm, like there's some interface stuff that you need. Like you need this like struct my extension and then like this macro stuff. But let me see. Let me see my. So here, like this is the actual like node that I'm kind of making, right? It holds all the data. So when I instance this in Godot, like this data is kind of allocated on the Rust side, and I can show you. Like this is kind of what gets called when I create this blocks node, right? It creates a new Rust struct. It has all these fields filled out, and that's kind of that. And then here I have the implementation for this, and yeah. So every time you see this func like macro keyword here, it means that this function is exposed to Godot, right? And all the types here have to be something that like the thing that I'm using knows how to convert from Godot to Rust. Right? But these things can just call normal Rust functions and they can go into threads. Right? It's proper Rust. It's running well, not that much overhead, I mean. Well, there's some overhead stuff, but I'm avoiding it. So how I used to do world saving is that I would take the world, I would make it into a byte array, and then I would pass it to Godot, right? And then Godot would handle the actual file I/O. But for some reason, passing the byte array to Godot took 600 milliseconds. I'm like, what? Like my files aren't even that big, and it just took 600 milliseconds flat every single time I wanted to transfer a, you know, like a byte array of save data to Godot. Like, bro, what the hell? Then I changed it so saving and loading uses pass in a path that's a string, and then Rust itself handles the file I/O. So there's like some weird stuff. And also I did previously try to move into Rust, but how would I say? Let me draw this. Like, let's say we have like a bunch of small tasks, you know? These are tasks. And then let's say our like Godot Rust border goes here, and you use Godot to like call each one of these individual tasks. Right? In my experience, this is bad. Right? You shouldn't be doing this. What you should be doing is you have one thing, and this is, this is Rust, and this is Godot. And then you like basically like call one function, and then the Rust side does the like little tasks, like everything in there. And an example of this would be, let's say you are building physics. You want to basically say once, oh, run physics, and then it does every single task. You don't want to have a Rust physics body, or Rust physics bodies, and then on Godot say, oh, you move this way, you move like this, you move like this, you move like this, you move like this, and you move like this, right? Because even if this code is all in Rust, like you have to go through this interface a lot of times. I'm not sure if that should be a problem or if it really is, but in my experience, that is a problem. And it's like, the smaller you make that interface, the better. Yeah, yeah, yeah. So first, the touch prevent sounds like the initiative and here work. Here work making this work. I'm not exactly sure what you mean. Well, yep, yep, yep. That is yeah. But so far, working pretty well. And I have my like chunk meshing and whatever. Right now it's a blocking operation. So if chunk meshing took 35 milliseconds, then you wouldn't see the results like after 35 milliseconds. The game would freeze for 35 milliseconds, and then you would see the results. You wouldn't be able to run in the game and then like see the change after it's done. So I'll have to either fix that or make the meshing really fast. Those are like the two options that I have. And honestly, first I want to just make the meshing really fast. I want to see if I can get away with that. Most likely not. I'll have to make it non-blocking anyway eventually. Making a game with this or learning mostly? Well, if I could have 100% trust in Microsoft, Mojang, Minecraft, that combination, I would probably learn Minecraft modding and just make custom maps. And with mods and do stuff. And if I could like sell them on storefronts, that would be great as well. But I don't trust them. Right? It's like Minecraft has been heading in a pretty weird direction recently, at least in my opinion. And it's like I don't want to make stuff that is completely dependent on another game's existence and their like choices on what they want to do. So like I've had this thought many times where like, oh, I could make something cool in Minecraft, and then I go into, but I could also just make my own game. It would make a lot of things easier. So now I'm making my own game. Or like, well, more like making my own engine to make games with, right? So I do have a plan of making games, but I need the tools first, right? And I'm not really interested in making like a one-off game, if that makes sense. Like, just going into an engine, like making the game, and then like after that, kind of being in square zero. I mean, of course, I learned something and I have some code snippets that I can use, but I think you can understand what I mean, right? It's basically you start at square zero like all the time if you just make one-off games. Well, I might be wrong about that, kind of. But if I make my own engine, then certainly I'm not starting at square zero all the time. It's like I have all my tools and everything I've accumulated all the time. I'm planning on making some good map editing tools, so I can be like, oh, this is position A, this is position B, fill everything in between, like with this material. Stuff like that. And just make my own workflow that I like the most. So, mm-hmm. Yep, yep, yep. And I'm also skipping, like, making the renderer part, because I don't want to sink a few months into that right now. So, Godot can handle the actual, like, triangles part. Thank you, Godot, very cool. Also, UI, I don't have to, make everything myself. That's very cool. And also, eventually, audio. I don't have to handle that myself. Very cool. These are things that don't really interest me, but I think I will eventually get to doing them myself, maybe. But physics are fully custom, actually. They're fully mine. You know, we have stair stepping and whatnot, and everything kind of works. We have sneaking, so if I press shift, I can't fall off any of these, which is pretty cool. But if I break this, then I can't fall. But that's intended. And networking also, I'm planning on doing rollback netcode, so that's going to be another fun headache at some point. Because I really like the idea of only sending inputs over the network, and you know, so like if you have even a building game, you never have to send world data. Like except like when a player joins, you have to send the world data. Make sure you're in sync, and then any like block placements, any like tool uses, whatever, they're automatically synced because your inputs to the simulation are the same. Yeah, exactly. That's why I need my own physics as well, right? And I do have some floating point stuff right now, and I've heard scary stories about floating points being able to break determinism. But yeah, I'll have to convert it into integer math or see that it's not a problem. But I don't know. I feel like using floats and relying on them being deterministic is like a ticking time bomb. But we'll see where everything goes. Yeah. Yep. The current things that are lacking that I would like to not be lacking are, one is raycasting. I just right clicked. Wait, did the block even go anywhere? No, it didn't. But you can like place blocks through corners sometimes if you're really precise. Oh, because the current system is not good. Doesn't seem like it wants to do it right now. That's fine. Well, I mean, what would I say? I would like to say that it's not that complicated. Um, but I may be wrong. You know, it's like you have to make sure all your entities in like any lists are in the same order, or make sure that the order they're processed in like is irrelevant. And you know, don't use floats. Smile. And make sure the inputs are the same. I feel like there's not that much more to that. I feel like physics stuff like starts out deterministic and then you make some optimizations and then it breaks. Unless you start out using floats, then I don't know. But anyway, greedy meshing. Greedy meshing. And here, you can see how I do the like multi-threading right now. You know, like I just have. Well, I do light propagation in a separate thread. But it's all like within the scope. And this is already in the main thread because reasons. I don't even actually even have to get the join handles here and like join these threads because this is right to this hash map. Like they access data and write to here. And then here I use the like data from these two functions. And yeah. And rebuilding meshes, we have another scope here. And to spawn a bunch of threads, rebuild the meshes, and at the end we join the results, and then actually like this is the stuff that I couldn't put in another thread. On you know, making variant arrays not allowed on not to can't move these between threads, basically. TLDR. For some reason. And then also moving array meshes also is illegal. I'm not sure if you can move references to nodes through threads. That might be a thing that I haven't tested yet. So I'm gonna have to see if that works. But yeah. Yep. Do I have yeah. So I just made this little struct to help me. Where I just have like the results in types that I can actually move between threads. And then I just use those here. Yep, up, 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 up. Oh. Alright. Yeah. I mean, I'm also thinking, like, I saw some videos that, how would I say, like, gave me the idea that you might not want to send a mesh like this over, like, you know, as a list of points and list of indices and whatever. You can just define your own data type for the mesh, I guess, and you just have to process that on the shader side, you know? So one way to represent a voxel mesh like this could be they have the location for a mesh. Well, you have a location for a face, you have the size of the face, and then you have the normal of the face, right? And those are the only things you need. And I don't need floating point precision. I could do just by having positions. Like if I have a block, then I just need to have 1/16 of a block precision. That's how big the textures are. And I don't think I need like smaller increments than that. So that's the thing. And if you can save some bytes, then you don't need to transfer as much data between the CPU and the GPU, and that's good. Thumbs up emoji. But first, I have to get the logic of the greedy meshing. Ooh. I just bonked my chair. Hopefully that wasn't too loud. Anyway. Let's see. Rebuild chunk mesh. I was thinking of doing this in a few passes. Where first we note down a bit more abstractly like where the faces are. First, yes. So my mom is laying at the couch, like right behind my door, and she started snoring. Like, hopefully it doesn't get too distracting. Yeah, so first pass is we note down face locations. Maybe. Then we have our second pass. Or, you know, this is a part of the first pass. We merge faces on one axis, right? So if we have let me actually go into the game. It's way easier when I can place down blocks. If we have a plank thing like this, the first time around, we're gonna go through and we're like, okay, this is a face, this is a face, this is a face, this. And even during the first phase, we might just be able to go like here, okay, these are actually the same, right? Like when we place this one, do you still remember the last phase? And we're like, oh, okay, these are the same, so this should probably just be a combined thing. And then we go to this one, we can also see, oh, this and this are the same material, we should probably combine these to be a strip, right? And that's in the first pass. And in the second pass, well, I mean, still in the first pass, we make all these to be strips. And then the second pass, we go through this direction, we take a look at all our faces, whether they were combined or not. And then, you know, we see, oh, these actually have the same length, the same material, let's combine them. And then next we consider this strip, and oh, it's the same. Let's combine. And I feel like that shouldn't be too expensive. It might actually save performance because we don't have to create so much mesh data. We're cutting down on the amount, which is good. But yep. And even noting down the... Yeah, okay, I started thinking about something else. Yeah, in memory, when we're doing this and we're like looking at the materials, it should just be the integer index. But when we like quote unquote commit this to the mesh, and if this is one big triangle, let me just note down the like UV coordinates for the whole thing, and then the shader will just scale the texture properly. Oh, yep. I think that's a fine idea. So right now, we immediately append each face directly. That has to be changed. And to append mesh, we say we have a texture ID, we have atlas size. Yep. This might have to change a lot. First, we need our immediate, like intermediate representation of our mesh stuff. Also, let me check something. Did I forget to ping the Discord server? I think I did. Lol. Alright, anyway. Half an hour late. Well, better late than never. But also, if you have like links to your own stuff, if you have anything to show, then I'd be interested to see. But I also know the feeling of not having anything ready to show and people asking. Yeah, the intermediate representation. Let's see. Mesh face. What do we need? We need material. It's a U16. We need the position, I guess. And then we have this size. I have to check if I spelled width and height correctly. For some reason, there are words that I get incorrect. I feel like height is supposed to be TH. No, it is HT. Holy. Okay, they're correct. I was just not not confident in the spelling. We have position, so this is gonna be like top left or something. Width height. I don't think I need anything. So let me do cargo check. What container do I want to put these things into? Well, let's make the mesh traces first. Yep. Here's where we actually append the mesh. We just want to create a new mesh face. We complain about that, that's fine. What is our position here? Have it further up. I guess we need to get this data from the mesh itself. Okay, I'm gonna need different representation of the actual like small models, as I realized, because currently these are like already like raw meshes. That makes sense. If I place this down, like these triangles were defined in Blender, right? Like there's a line like going through there, this line going through there, and we literally just placed this mesh data into the trunk. So it's not the best. I do have to somehow. Yeah, well, I just need to change the representation form of the data. That's all. It's nothing more complicated than that. Yippee! I get to redo all the meshes. So we're gonna have our own thing. I could start now by just assuming that everything is a full block. And then later re-implement all those other things. I think I'm gonna do that. So I'm just gonna hardcode everything to be a full block. So what is our position of the face? We're gonna have our position, which is somewhere here. Yeah. Where am I? There we go. Position is pos. I probably have to dereference this. Oh, I don't? Okay. Just put some placeholder data here. Oh, wait. I'm dumb. These don't have to be 3 numbers. Okay, where am I? Has to be 1 I32, and this has to be 1 I32. Okay. We don't want to start the position. Let's assume that this is the center of the block. So we need to offset the block edge. I think I'm gonna do this in entity space coordinates. Or I'm gonna do this in some other space. I did say that the only precision I need is like 1/16th of a block. So I could do it in that space. Like pixel space, I guess. So this is gonna be just a raw block position. Okay. I want to do this in entity space just because I already have the conversion stuff kind of ready for that. So now this is an entity space position. Not necessarily lined up to the like entity world, but that's fine. And what do we want to do? We want to make sure this is at the correct edge of the block. We need to know which face we're placing. I guess I could kind of cheat, where I take the offset position, and I take my current position, I take the average of those. Does that work? Not quite, actually. Damn, if only. Well, I would get this like centered position on that axis. Do I want to use extended space? Damn. Let me think. The good thing I see here is that I can, how to say, I can make this meshing very, like, give a very optimized result in a very neat way. Right now, if I place some stairs, for example, or I place another stair here, the way that we know that these faces should be called is just I have hard defined flags, basically, to say that this face of the stair is full, and whatever like block is here, those faces should be called. Oh, I forgot about stair connecting. But you can place any block here, and this face will be called because this is a full face. Right, but we have two slabs next to each other. These faces are not called because slabs don't call any faces around them, except the ones they're on top of, right? But if I have this intermediate representation with faces, then I can just check if the face should be rendered. Yep. I'm just trying to think about how all this should flow. Yeah. Okay, okay. I'm gonna 16 for now. I'm gonna have a separate constant for this. And these faces, they're gonna be centered. The center position, then we have a width and a height, because that makes coding this easier. Actually, I can first take the average and then multiply it. No, I can't. I don't have precision. No, I can add, then multiply, then divide. That will work. Yep. We're gonna add positions. We're gonna take our offset pos and our pos. These have to be borrowed, I think. Let me check. It doesn't cry, and if I remove one of the borrows, then it will cry. Yep. Then we multiply. It's to be borrowed. We say pixel size. And actually, I can just multiply by half of the pixel size. I don't need to divide this, like... Yeah. That makes sense. That's actually very good. That directly gives me... the correct offset for this. Genius. Mesh face. So now this position is going to be where we want it to be. It's a bit of a roundabout way of doing it. I could have maybe just had the offset as a variable and then just use that directly, but who cares? This works. So we take our mesh face, we have the position, and now we need to have the height and the width and the material. I guess we also need to indicate which way it's facing. Or then we just have separate arrays for different like different directions that these faces can face. I think that makes more sense. These faces that are facing like X plus are not gonna ever interact with faces that are facing Y plus, you know, and Y plus is never gonna interact with Y minus. So these should be completely separate things. And that actually ties into another optimization that I have in mind that I totally came up with my own and didn't steal from a YouTube video. But yep. Guess I have to go up here and define the face vex. I guess I'll define the type explicitly here. I'm so glad I have a mute button that I can just press really fast. So when I cough or something like that, what did I write? If I cough or something like that, it doesn't come through to the stream. Top, bottom, front, back, left, right. I do also need to have the correct thing here. Go. Nothing should be wrong there. Damn is wrong here. I need to borrow this. Perhaps. Maybe I have to do it like this. We'll see what Rust wants from me in a second. Okay, that's fine. Middle borrows of these. And we have our face, and then we say, what was the variable name? Face collection dot push new face. And height and width are both going to be 1. Material, we actually know the material already. Where is it? And I guess also, I shouldn't note down the material, I should note down the texture ID. These are slightly different things, but if I have, I feel like a genius now. Even though it's very basic. But it makes a difference. If we have dirt and grass, if I have a bunch of grass blocks here, and then we have one dirt block in the middle, this should still be one face down here, because it is literally the same texture. We shouldn't care which one this is. Up here, we're going to have a different composition, because these are different textures, but on here, it's all the same. Yep. So I'm going to change the, how we call that, mesh face, texture ID. Yep. Two, 4, there we go. We have texture ID. I think we already got it here, right? Oh yeah, okay, it's right here. Oh, it's already like that. Okay, nice. What? Okay, sure. I need to dereference it. Good. I guess the first optimization would be to look at the last face that we placed. We need to access the mic, check if yeah, the only thing we did check. Oh, actually no, there's 2 things to check. Or are there? Let me think. There are. Yep. We need to take the last one. Okay, so let's say last face equals to face collection. How do we get the last thing from it back? Let's see. Mr. Kiki, thank you for the follow. I hope I didn't butcher your name. Let's see. Yeah, okay, latest elements. Last element. Atom to pop. Oh, okay. Sure. We just say last. Alright. Okay. That's some good syntax. I think we want to do iflet here. This. I'll do some operations in here. Yep. I need to clear all these errors at some point. This is annoying. Oh well. Oh well. Da-da-da-da-da. So if we have a face already, then we need to check this is face next to us. Does this face have the same texture ID? Yep. This is the plan. Now I just have to make that code instead of English. Guess I have to make the new face before I try to compare these. Yep. It makes it easier. Check that this is correct already. There's nothing wrong with this. Nothing seems wrong. That's good. That's good, that's good. I might change this to be a lot else later, but we'll see. So the texture IDs are the same. And we also want I guess we need to check that our edges connect. I was thinking, because we can have, even if our face is, let's say our face is facing upwards, we can still have a variety of positions that face can be in. Right? So if we go here, we have our stair. Here already we have this face and this height. And, you know, this face and this height. And also, oh yeah, this can also be different. For example, like these faces are, well, if only the stairs didn't connect together. Let me make this a different material. No, I changed the other one. Anyway, what was I gonna say? Does this connect? This connects as well. We have a slab. Basically, TLDR is there's a lot of like cases where we can't merge these phases necessarily. But currently we only have to deal with full blocks, so it's fine. We do just need a check to see if the position is the same. Well, the positions aren't the same. But it's like this position plus the height is the same as this position, and then we need to see that the width is the same. I think that's it. Yeah, this position plus this coordinate has to be the same as this, and then the other size has to be the same. Yes. I'm gonna put this inside of the if statement for now. I can make it more performance just pretty later. Okay, so we're gonna have this is gonna be our, so if we assume that the bases start at the top left, we're gonna get the bottom left of the last phase, and then we have to compare that to our current phase. The last phase bottom left, what is it gonna be? It's gonna be, it can change actually depending on what direction we're doing. It's a bit annoying. Let me think. Dun, 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 dun. I guess I could cheat and I could write the phase logic to always happen in like a certain axis. And then later, when we're turning these phases to actual meshes, that's when we like rotate them to the correct orientation. That would mean that when I'm making this, I don't have to worry about like what direction we're facing. That seems like unnecessary extra work. So it's gonna have some consistent directioning going on here. Sounds fine to me. But I'm gonna take a really quick bathroom break, and I'll be back after that. So, BRB. Yeah, we're so back. Yeah, also I thought about this a bit, and looking at the last phase, not the best approach. We might miss some stuff here. Let me show you an example. If we have, but it might not actually matter. It might be good enough. We might have some situations. Doesn't really apply. I would need a block where we have, how to say, we need another surface that faces this direction on this model, and then this thing that I'm trying to say would be true. Actually, this... Oh, actually, the top face is perfect. So, let's say we place down a stair. We actually place this bottom face first, right? So we take this block surface. We take the surface, and when we place down this, we see, oh, the last surface, it lines up, whatever, let's combine. And then we place down this face, we see it doesn't combine with the last face, and then we place down this face, and we know this is the latest face, and it's not going to combine with this. I guess the easiest solution to that, actually, is to not update the latest face until you've placed all the faces for this block down. But I don't know, I feel like there's still some issues with this. And I also feel like there might be issues, but they might also be kind of irrelevant, where this is looking at the last phase. It removes a lot of iteration later on, like we don't have to check every phase against every other phase. And it's like good in 90% of the cases. So I might not have to worry about this at all. Yeah. I think the most iteration you need to do is when you place on a face, you just need to check against every face of the last block and see if there's anything to merge into there. So every face of block you place down checks against the faces of the last block. And that's how that works. Yep. That seems like the optimal move to me. And for now, since we're assuming everything is a full block, since we are assuming that everything is a full block, what does that mean? It means we always placed on one face and we just have to check the latest one. If we also have the other direction of our optimization, can we help this process anyhow? Because we don't want to check every face against every other face. I guess there's... Okay, so these are going to be sorted a certain way just by by the nature of how we're placing these down. I think I can get some early termination logic going on very easily. Yes. So if these, if this is already a large face, or any kind of face, it's combined, we know that we don't have to look at anything that came before this. We're not gonna be able to combine with anything before. At least I think so. And then we would go forward. And you know, we have, I'm just gonna put this separately. Actually, no, I'm gonna use a different material so I can actually differentiate between these. But imagine these are the same material, right? So we're gonna go forward in our array of faces. We're gonna iterate through. We're gonna see that none of these match. And I think when we get to here in our list, we might see that these match. That works. I don't know if you can do early termination after that. Or then you see that these don't match. Like, let's say these are actually different texture IDs. You see that these don't match? And you can assume that there's no other face occupying the same exact space. Then you can kind of just know that nothing else can combine into. And then you can just skip iterating through the rest. I'm not 100% sure yet how you would do that. I'm pretty confident you can cut down on a lot of the iteration. You don't have to check every single face against every single other face. Yep. Okay. So now, since we're gonna have the same rotation for every face, what do we say new face? We say new face here. We're gonna turn them later, so we don't have to do this multiply and find the average thing at all. What I do need to do is I need to take our current position. Don't need to add it, I just need to multiply it. Is this actually enough? I don't think this is good. We multiplied by pixel size. And then to get to this surface, I'm gonna add. I'm gonna do add position. And what do we add here? I need to choose an axis. I think in my mind we're gonna iterate on the y-axis. I'm imagining a wall and we're combining textures on the wall. So X and Z. I guess if we're on a wall then Y should be one of the moving parts. Yeah, no, that makes sense. We're combining texture on a wall and Y plus Y moves down. That's the orientation in my head. So the position of our mesh, we're gonna have the top left. So we assume that this is in the center of the block. This position. We need to get to there. Do I need to actually think about it like this? all the different axes are on their own array anyway, I'm gonna transform those spaces anyway. Yeah, I only need to do displacement on one axis. What do you think? No, I'm gonna do multiple axes. If we have a face that starts in the middle of the block, we want to be that at 0 still. So this would be a face that starts in the middle. I want to like go to the top left. It's very fun to try and visualize in my head. At this middle of the block position, we're gonna go forward. Let's say that's x plus. Now we're there. Now to go up. That's gonna be a positive y. And then we want to go left, which is, let's say, negative c. This is gonna be the spot that we start. This should be the top left on a wall. So let me actually try and draw what I just... Actually, no, I can just go in the game. So we have... Actually, yeah, let's say... This will be great. Oh, this is not a block, it's a stair. Yippee. Let's go to the middle. This is approximately the middle. Or it's exactly the middle. And this is going to be... So what I just try to think about there is we have our position. It's going to be in the pixel size now. And then we go a half a block forward on X. So we're on this surface. Then we go half a block up. We go here. And then we go negative half a block on Z. So we go here. This is how I'm thinking about it. So this is like the wall. You can imagine more textures here. This is the wall where we're placing everything. And we just went from the middle to this top corner. And that's our position. And if we have different kind of models in the future, for example, like a stair, where, you know, one of the faces is going to be cut off from the middle, then, yeah, we have still the same position, but it's going to be different size and whatever. It all checks out. It all checks out. Damn. I feel like I either get this working first try, or then I'm gonna curse myself for not having debug visualizations of this stuff. Oh. Let's see. So we have our new mesh face, the correct spot, top left, on the surface of the block. And on height or width actually gonna be pixel size and not one. I guess this shouldn't be called pixel size, but pixel count within full block or something, but I hope that name makes sense to me in the future. And I won't think about what I mean by pixel size. What is this? Okay, so the bottom left of the last face is going to be we only need to modify the Y. I'm gonna add to this 0 on these axes and negative pixel size on this axis, right? Oh, forgot the semicolon. Yeah, we take the position. This applies for full block. And for a... Actually, we don't want to take the pixel size. We want to take the actual height of the block. That's what we want. Why did I just get an error that I didn't get before? That's interesting. Anyway. Alright. Multiply position. I guess I removed this bar or something. Very strange. Okay. Fair enough. Take the height. Take that away. We go to the bottom left. And now we need to know if the bottom left is the same as our top right. I don't think I can do a straight equals operation here, but that's fine. I'll just have to do it manually. Oh, I can do that. Interesting. Alright, that's good. I can just straight compare these. Alright. I thought you couldn't do that. Is there something interesting going on here? Let me test this real fast. If we have 0, 0, 0, what does it say? It's fine if we have different size here. Okay. Okay. So it actually just works. Good stuff. If the positions are the same, and if last face dot width equals new face width. So after all these checks are true, we can now combine the face. These can be combined with one if statement. These also technically could be one if statement. Oh, actually, but it is more pain to do this as one than it is maybe worth. Because I calculate this here, I could calculate it inside of the like if stem and stuff, but whatever. Who cares? I wish I had a like logic flow thing where what would I say? Like if any of these conditions are not true, I go into one known else branch. I'm so sad that doesn't exist. Or I guess I could make a boolean out of these. Yeah. It's kind of cheating, but whatever. Mm-hmm. What do we think? Yep. Mm-hmm. Now, if we combine the phases, what do you actually want to do? We want to take the last phase. Oh, this is also... We need to assume that the phase actually exists. Damn. That's rough. I hate how this branching works, but... Too bad. I'm gonna do let else. Yep. Or... Let this... If not this, I don't think I need to do anything else after that. Yes. This is gonna say push this. I have two places where I push that, but that's fine. Yeah, I just need to copy this through. And then we do continue here. And we say height. Combine yes, we access the height here. So we plus to that. And what do we plus? We plus the new phase, the height. That should be correct. Damn. Oh, I wrote this incorrectly, that's why. I recently played Psychopomp, and the music is just stuck in my head. Decent game. Decent game. Let's last phase is phase collection last, else, then we just push the new phase. We continue, yep. And now we have the last phase. Check if we actually want to combine. Move this Boolean declaration here. Yep. Yep. Oh, and this let else needs semicolon there. Oh? Can I do like last minute or something? Oh, okay. Nice. That was easy. Easy error to get rid of. Okay. So we have a face. We take the face. We see if we should combine. And if we do combine, then bada beam, bada boom. We're gonna do it. I'm not gonna do any mesh appending stuff here. Still gonna save it for now because I feel like I might need this. I'm gonna do it above here. Move this comment as well. Okay. So we did the old thing where we append the mesh, you know, VP. Then make the new face. Check we have the last face. Check if you can combine, and then combine. And this should already be greedy meshing on one axis complete. Except that I need to turn these faces into actual meshes. Yep. Yep. Guess I can also comment the append mesh out for now. How does this append mesh function work? I don't need to transform this to work with the mesh faces instead. Oh yeah, I need more changes. Because this works in a different way. We don't take the rotation of the block into account here yet. We actually do need to do that. Or when we do take it into account? Hold on. We need to do the rotation before we go here, I think. I think that's the real answer. Or I need to access these separately. Where do we get the rotation? Block dot rotation, where would we get the block? We get it here. So we already know the block here. Then we have our lovely append mesh function. We're gonna skip over it. We know the block. Yep. That makes sense. Anyway. This is a shorter stream. It's been a lot of thinking. I need a break. All I'm gonna do is go do something else. I'm gonna check how big our raid party is and then pop off somewhere else. Let's see. I love how fast my Twitch page loads. Alright, 3. That's fair enough. We're gonna go to Pigeon. Pigeon is a great guy. Again, shorter stream, but that's fine. Do be like that sometimes. I'm just running out of the juice. But yeah, next time, more video meshing. I might do this offline a bit. Maybe? We'll see. I'm live pretty much every day at the same time. Nepredator.com/stream/schedule. Anyway, yeah, have a good one. See you later. Wah.